Okay, so I'm going to try this once again. So I am investigating a problem in rustc, and I want to demonstrate how to use Pernosco as an investigative tool to use when looking at problems in code in general, but in particular in Rust, the Rust compiler. The particular problem I'm looking at is that I have this branch of Rust, the Rust compiler, where I'm trying to add a slightly new feature. In particular, there's a known bug where async functions, if they can have a situation where they will double their size of their arguments, in particular in terms of the amount of state they capture. Namely, an async function like this, it actually the way it works is internally this turns into a block that returns something called a generator. The generator here will capture the local variable arg, the parameter that's there, as a reference to a variable outside of its scope of the generator, and then it'll make a local copy of it, and it'll actually allocate a separate spot for it in its local generator state, which means you're duplicating the amount of storage you need. Here, this is an 8 kilobyte object, and so the actual generator ends up occupying 16 kilobytes. Okay, I've made a little demonstration bit of code that tries to experiment with a way to fix this, namely to specify as an experiment a way to say, look, I want this local variable to actually reuse the same slot in the generator that the up variable had. And so this is the very hacky solution. There's reasons that there's more general systems that we like to use that don't require this kind of attribute, but for right now, I just want to try out the simplest thing that could possibly work with a lot of help from me. And notice also, in this case, I'm using an explicit asynchronous block because this code is just the way that I wrote this to have direct control of what I'm doing. And in particular, you can very easily avoid this problem here by just creating by just avoiding the let bound local here and referring to an upvar directly and making your own async block. So the core problem we're trying to eventually address is the fact that the desugaring of an async function turns into one of these async blocks and introduces this let statement here effectively. So the problem is that on my little bit of code that I'm experimenting with, it does not work. Why doesn't it work? Because it ends up panicking while it's running. After it runs, something goes wrong where it's this broken mirror that I've created somewhere here that has invalid structure. So what I'm now going to demonstrate is I'm going to try to investigate this using Pernosco. Pernosco is a tool where you can take a binary that you've created. So for example, the Rust compiler itself, right? I'm running the Rust compiler right here in this command line and invoking it on that example file I showed. And I'm piping the output to a log file, and I've got some environment variable here that tells it I want some instrumentation output to see out internals. But the crucial thing is I'm actually gathering a trace of the run using RR. RR is a special tool that gathers that trace, and then I'm submitting this RR trace to the Pernosco service. So let me go to my account on Pernosco. So going to the Pernosco site, and I'm looking at my account. I'm going to go to the trace that I submitted here late yesterday. And here we see the Pernosco interface. In particular, there's the standard output that is just like the one that I had in my terminal, except that it's black on white instead of white on black. And also the Pernosco system, it by default has these buttons to load more information. I'm going to go ahead and just hit this button here that fills it all in, just so I have all of that text ready to go. And now what I'm going to do is I'm going to experiment with trying to find out what is going wrong. What is it that it's seeing? Oh, I thought that it would load all of it. Anyway, let me try that again. Try that same button again. Maybe that button meant a different meaning when I was scrolled all the way up like that. So what I'm looking for is the start of that stack trace where, oh, look at that. I thought, you see, I was given the impression that that would load everything, and yet it clearly didn't. Okay, well, that's news for me. It's fine. It's fine. I'll just use the buttons. Yeah, I'll talk to the Pinosco developers about what that is. Maybe I misunderstand what this button does. I thought that was yeah, it says load all query results. That's what that says right there underneath my very large mouse cursor. Okay, here's the backtrace, and here's the message that's saying about the out of bounds field result, field one for place tie. And what I want to try to do is figure out what's going on with this field and where that's coming from. So the interesting thing about Pronosco is you can click right on a bit of output like this, and what happens is it jumps right to the spot in your trace where that output was generated. So it's actually effectively put us in the same context the machine was in at the time when that output was generated. And so you could, for example, walk the stack right here to see about when this information was emitted. And it turns out that's not that interesting to do here because the way Rust works, it buffers up all that information about all those diagnostics that were being emitted and flushes them all at a later point. So seeing the stack trace at the point where this was emitted is not actually that interesting. But the other thing that Bernosco gives you is in addition to the stack trace at that point, it gives you this data flow where it says, look, you were emitting information. I clicked, where was it on the field one, number one, I think right here. Yeah, it's showing us here are all the places where that number was copied, where that number one was copied from place to place in the flow of the data was copied from place to place. So if I click here, for example, it'll jump to the spot in the output where the spot in the execution where that was copied from one place to another. Now this is just another write because you can expect that there may be many places where we write into a series of buffers. And what we're trying to find is the place where the original one was produced. But we can keep going backwards through this and keep paging backwards to find other places where this was copied from place to place until we eventually find the one that we care about. So this is still flush delayed. I don't think that's what we care about. I'm going to take another step back. I'm going to jump 2 steps back and see how that works out. So here we've got flush delayed still. Let's jump all the way back here and see where that puts us. It might be too far. We'll see. Okay, well, partial, that's interesting. Why is there a partial eq there? That's very interesting. Emit message default. Nope, we're still in flush delayed. Maybe I'm misunderstanding how far this can go. Well, let's see. Where do we end up here? I'm trying to see where that one came from. And now it's gone. Oh, it was up here. It was this place one. And it seems like all the spots where I was looking are not interesting, which is too bad. I was hoping that we'd actually see the place where that came from. But the other thing we can do is we're looking right here, and it says, look, this is pushing from SC char, right? This thing here, whatever SC is, a styled character inside of a styled line. Well, if we have a build of Rust that doesn't have optimizations on, we actually can look pretty deeply at this kind of information to say, okay, I want to see that character, that one is a local variable as part of SC. Show me where that came from. And again, we see a data flow where the character, we see where it's copied from place to place here. And so we can see, for example, that we had a write stir, I put S here, a couple places where we did a replace. It's interesting, though, the value being passed along is a 49. Why does that change to a 1? That's interesting. I'm not used to seeing that happen inside one of these data flows. I don't know if that's a Pronosco bug or if it's something we're doing something on our behalf. So push to 1 here, right? That's what C is here, I think, in this for loop. Yeah, C is 1 right there. And so this is a string that has this stuff in it. If I click in this string, I'll now get another data flow into when that string was written into. So now we can backtrack through here, maybe the same kind of thing, where we're going to see, okay, this string was formatted all the way up here. Okay, up. And actually, this came from somewhere. This came from all the places where we have like new type index. There's a macro that generates a bunch of code associated with this. So we either took a step too far back or we're inside some code that's called it's hard to see because we're inside of a macro expansion. That's okay. We'll just jump back over here, using the back button on our browser, and maybe try here instead and see what this takes us. All right, so now we're instead of a right stir, where we're doing a visit projection element, and it says fail. And look at that. So we've stepped backwards. Now, I'll be entirely honest here. I could have probably grepped for the text out of bounds field, this for this, right? That text was actually pretty apparent in the text of the output that we were looking at. But the crucial thing I can't stress enough here is that this approach generalizes. That I just found a piece of output, a little bit of output that I was interested in, and I was able to tease apart and work backwards through all the places where it was copied to find the place where it originated. And that gives me a lot more information than about the context of where that thing came from. Here we can see this is a failure, that's out of bounds failure. And this particularly, it's an out of bounds failure. This is a closure that's called from within some other spot. So in fact, we want to see, well, we may or may not want to see how that what the context was for where that closure was called. It's somewhere deep within some type visitor that's working its way, that's traversing this thing. So the important part is perhaps to see where we were visiting or to see which pass this is. It's validating a whole body for something. I'm sort of more interested in knowing the thing that was constructed here and where it came from. So maybe let's try to focus on that. That I want to see what thing was being constructed. What was the body that we're trying to inspect here? So in particular, there's some sort of body of mirror that we're looking at, and it's a set of basic blocks. It might be a very long set of basic blocks. I'm not sure if we actually going to. I'm not sure if it's going to be productive to actually inspect this whole vector because I don't know how long it is off the top of my head. Even scrolling here, we can see that it might consist of many. It's 16 basic blocks. That's not that bad. The interesting thing to me is whether I can quickly identify this statement that I'm looking at here, where it's this projection out. And I don't know. I can't quickly tell if I'm going to find it this way. So I think I'm going to take a step back now and go back to what we were just looking a moment ago. This is the other thing, actually, before I do that. The other crucial thing you can do in Pronosco that's really cool is you can say, look, obviously you're going to be traversing a lot of stuff here and looking at a lot of various places that may or may not be interesting. One thing you can do is you can say, look, I'm looking at this spot right here. And usually there's a way to say, okay, if I'm looking at this spot, it shows up in the notebook as something that I can click on. I'm a little surprised right now that the interface is not quite working the way I expected. Maybe it's because I need to reload or something. But my usual experience here is that when you bring up the notebook and you have a certain spot you're looking at, that it prompts you with that with a new entry in the notebook to say, oh, I want to learn more about this particular thing. But I'm not seeing the prompt here, so I can't actually save. I was going to try to save my context so I could jump back and forth easily and take notes about what I'm looking at. But since I don't see it, I'm going to go back. Again, I'm seeing lots of things that report to the Pronosco folks as like oddities in my experience using the tool right now. But the point is, the biggest point of all that I'm trying to make is that we were able to jump into the code and traverse in a very direct way through time, through the trace of the instructions that ran, and inspect things directly. So at this point now, maybe the most interesting thing is the fact that we've got this location, this field access. F is the what is F here? F here is, where is that bound? It's up here, this projection element. So something we can do is we could try to work our way back up the stack to find where this occurred. You can also just click on a line number like this. The orange is the things that are like within this current execution, like this function called this closure. But what we really want to do is find these lines that correspond to outside the closure, I think. Like we want to find particular where F, like I'd like to know where F came from, for as an example. So if I click on this 222 right here, we get a list of all the executions in the trace of that line, which is a lot, right? And just picking out which one would be like a shot in the dark, except that we've got this green line right here that shows us where this execution is, where we are right now with respect to the sequence of invocations. So I can click on that validate line, and now we've jumped back to the point in the execution that would correspond to this line. And now the notebook seems like it's working properly, where I can actually say, this might be interesting, I want to save it. And now the notebook has stored as a red line here, or I could pick a different color if I want. I could make it be yellow. The point is now when I explore other points in the space, that red line shows up as a point in the timeline of my program. And likewise, I might be able to find it in the execution of the standard. Yeah, here it was in the standard output where we were at the time when we were running. So the point where we were right up here, that corresponded to this point in the notebook, this corresponds to this spot in the standard output. So somewhere between here and down all the way here where we are currently. Oh, that's what it is. You can click on this button to go. If you're scrolling around in the standard output trying to find something, you can click this thing to jump to your current spot. So all that output was generated between here and here, and you can see this visually directly by via this interface where you get these colors to really tell you about these kinds of points in time and their relative position. Okay, and the only other thing that I sort of wanted to maybe explore here was this whole question of, what is F, and does that help us figure out what went wrong here? And unfortunately, oh wait, so yeah, let me jump back to this spot. Right, so in this spot that we have interest, the one that I marked in yellow, F is 1. And I can now figure out where does F come from? Because there's something wrong. It's claiming there's something wrong where this is an out of bounds field access of this type of F for this parent type ty. And the parent type in this case, we saw in the output before that we saw in the generated text. I don't know if I want to take the time to track it down, this output here, but it definitely spit out, the information about what it was. And that's probably the easiest thing to do, is to go and look at the text that was output. The other option here is to directly inspect this type description as its runtime representation in the compiler and see if we can figure out from that. And there's some cases where that's going to be the easier thing to do. In this case, though, I'm not convinced it's going to be that effective, because it's referring to something else indexed somewhere else. So I'm going to have to do some work to find out what this interning corresponds to. I don't, unless it's just an empty slice. That might be what it's saying here, now that I realize that. So maybe that is easy. I don't know. Anyway, the point is that this tool has given us some insight into this code base, and now I just want to see whether I can figure anything else out in terms of where this F was created, since it's something that violated, it's violating a broader condition, and I know the changes I made are relatively localized and small. I want to see if I can basically connect the creation of this F to something I did in my own work. It's possible I won't find it quickly, but I want to give it a shot. So here's the data flow to that F, and I can see here through the data flow where that 1 comes from, that we in fact create a generator slot. And I can tell you up the top, right off the bat, I am the one who created this type generator slot. I did that in my branch. So it made it very quick for me to scroll through this and say, hey, look, that code looks relevant to where it's something I did because I made that type. So I can see that, click it, jump there, and then look at the stack and say, yeah, let's go back to the point where we were in the code that I was working on, where that was actually created, which I have to remember is inside of compute layout, I believe, that our state transform. Yes, it's here. This actually is the work I just did. So this is the branch that I was working on, and this is where the 1 got inserted. So I've now tracked down the construction of this bad thing to the code that I was writing. And I did it by going backwards from the assertion to, and through the message output, through the point where the bad thing was detected by the assertion machinery, and then from there back to the point where I created it. Okay, and that's all I'm going to show off for now.